And we will start off with the guys from Indiana. And Robert?
Yep. Okay. So I'm going to talk to you a little bit about a platform that Internet2 Indiana and Stanford are working on together called the NDDI OS3E platform. I'm going to start out just quickly talking about the Internet2 community and give you some grounding in the way we think about a national innovation platform and what's important for this next phase of innovation. Internet2 was founded by 34 universities at the time that the Internet was privatized to create a new sandbox for the next generation of innovation. We've been focusing for the last 13 years mainly on bigger networks. And we're extremely excited because SDN provides the opportunity not only for us to build bigger networks, but to build much smarter networks, networks that we can program and turn into things that we want them to be and that our members want them to be. I would say that this whole talk only works if you accept the fact that when I say we have done, we have achieved, in talking about some of the things historically we've done in innovation platforms like this, that you're part of the we. This is a community of folks that certainly includes academia, but Internet2 has 40 corporate members, 11 of them are in this room today, and there's just a huge amount of collaboration that happens between academia and the corporate world. And in fact, many of these companies started their internet businesses based on activities that they had going on campuses and labs throughout the country. Just real quickly in terms of Internet2 and who we are, we do run a network in addition to being a network of people. We're just completing or in the process of completing a new stimulus-funded national network. It's got 17,500 miles of community-owned dark fiber. We're lighting that with an 8.8 terabit optical system. We've got a whole bunch of different things that layer on top of that. Probably the most interesting one for this audience is that we're committed to build a 40-plus node national SDN-based network that will be based on 1040 and 100 gigabit wavelengths. And that's an opportunity that all of us, we, have for innovation and testbed capabilities. I should mention in there that there's some partners, NSF, Genie, Indiana University, Stanford, Department of Energy's ESNet, NOAA, who all also collaborated in that. So what is this research and education community thing? You all have heard some talk about, is this thing really, or is this SDN OpenFlow thing really a research project, or is it ready for production? And my own take is it's both. The research and education community is going to be focused on problems a little farther out than some of the ones that we can actually implement today for production activities. And Internet2 is in a place in the middle, where we want to provide the platform for folks to innovate. Internet2, it's a community of thinkers, some of them in this room, some from academia elsewhere, and others around the world who work on advanced networking problems. As a community, we create markets. And I'm going to talk about this a little bit before Matt talks about the new platform we're going to create to hopefully create some new market. Our history is one where we've taken the best ideas, we've given them a large-scale prototype environment so that they can flourish in the time before they made sense commercially. And that's what we're going to try and do again. So to go backwards a little bit, the research education community has been at the center of most of the modern internet development and applications, and we think it's really, have been transformative to the information technology culture of the 20th and 21st century. This is an ongoing story. It's not simply historical. It's not simply that the first routers were developed here at Stanford and became Cisco and then already got out of this. If you look at all the things that have happened over the last 20, 25 years, most of them have started in this community of innovation that crosses between the corporate world and the research and education community. If you look at the return on investment on the federal project known as the NSFNet and ARPANET, and some of you were clearly part of that, that $225 million has turned into $240 billion per year market. It's an incredible statistic. The commercial internet, the first 3 or 4 major internet providers, ANS, created by Merit Network, Research Education Network in Michigan, Center for Seismic Studies in Northern Virginia created UUNet, NYSERNet created PSINet. All of those evolved into much bigger companies that we all know today. World Wide Web and browsers, early commercial sites were clearly from the R&D community. The Mosaic browser was designed to visualize data from CERN, the super collider in Switzerland. And the first web server was here at Stanford SLAC in the US. Reality was that in a time of proprietary networks, this thing had all the mass in it. It's where all the area of interest was and where things started to happen. It became the de facto standard because it's where the action was, where people wanted to collaborate. It's also a platform that many people argue, many people who now have big companies built on internet technologies argued wouldn't work. And that's part of, again, having an innovation platform and having a place where people can try things that may not work. Thousands of people can try things that may not work, so that one or two of them can succeed. Just a history of some of them. Stanford actually comes out pretty well on this list. Sun Microsystems from Stanford, BSD from Berkeley, Cisco, again from Stanford, Akamai from MIT, Arbor Networks from the University of Michigan, Facebook from Harvard, Google again from Stanford. All of these companies had their roots in this research and education community. You look at the first few, they're hardware ideas. And then it starts to move up the stack over the years. It's kind of fascinating. You start out with the hardware, you go to some of the middleware on the network, and then you see something like Facebook happen. In an era where people at home were working with 28.8 dial-up modems, dorm rooms, which had maybe a couple of 100 megabit connections per dorm room, were way out in front of what was available in the commercial sector. Created an opportunity for someone who's mad at his girlfriend to create a company that changes politics around the world. That's what an innovation platform is really about. So you can look at the whole ecosystem of everything we do in this room is evolving from the research and education community and the innovation platform that existed 35 years ago when much of the internet was open source or was freely created among collaborators who just want to get things done. And I think that's part of the opportunity we want to talk about today. I think it's fair to say that whole new markets have been driven and created from the innovation in the R&D networking community. And there are companies that have reinvented themselves. There are companies that originally fought the idea of this packet stuff and this IP stuff, who have reinvented themselves, and now it's their core business. There are new disruptive things that have happened. There are some companies that have gone away. But all of this has happened in an environment where we continue to lead ideas about bandwidth availability instead of scarcity, where we continue to talk about moving from proprietary to open. And we think there's still a need for this kind of incubation capability. And we're going to talk about a platform that we're creating for SDN that we hope will allow all of you and all of us as collaborators to continue that trend. A couple things about going forward. Obviously, people say, well, what are people going to use this for? I don't know. What I know is that if we create the capacity for innovation like we have in the past, we get it widely dispersed. NSF is working on a project to connect 100 campuses with SDN-type capabilities. We have regional networks throughout the country that are deploying SDN. We get a widely deployed base. It gets into places like dorm rooms and labs. You get into corporate partners. And you just let people play. The capabilities that we all see in SDN are going to turn into something wild. And so, again, that's kind of the platform that we hope to create. Internet 2 is making a major investment in this. And Matt's going to talk a little bit about what we're going to actually do.
Great, thanks, Norm. Got it. So great. I think that was a great lead into why build a platform from innovation and why the research and education community is the right place to do that. So I'm going to take from there and talk about the platform that we're building. So we partnered with Internet 2 and with Stanford University to build this platform. Some of the lead developers from the team from IU that are developing the software for this are here today. We have a demo outside if you haven't stopped by to see it. And so I'll talk a little bit about what we're doing, why we're doing it. But I wanted to start off with sort of my key takeaways from yesterday. I thought that the talks yesterday were wonderful, and I wanted to start with some notes because I think it's relevant to this. So, unless you were sleeping yesterday, I think you heard many times that networks are very, very complex, and that the pace of innovation is not keeping pace with the innovation that we're seeing in software and devices and servers and storage and other areas. Talked about how SDN is all about creating these layers of abstraction, defining the interfaces between them as a way to increase the pace of innovation. SDN is not just another protocol. It's not that thing that's going to fade away. This is not a protocol per se. It's a whole new architecture, a new paradigm for how we build networks and how we build networks into the future. And we're only starting to develop this. Some of us, particularly within the academic community, have been working on this for 2, 3, 4 years, but really, we're really at the tip of the iceberg here, and there's a whole lot more work to be done. Just to go over a little bit about what Rob hit on, innovation in universities. He talked about some core networking innovations, TCP/IP, routing, other things like that, as well as application innovation, putting 100 meg into all the dorm rooms and the things that could create as a platform. No one knew what those students were going to do when we put 100 meg in there. Why would you need 100 meg in your dorm room when most people have 28.8 at home? But with universities invested, they put it in there, and a lot of things happen because of that. Sometimes you have to challenge the status quo. When I first came to IU in 1999, I still heard these great, passionate stories about these crazy, free-spirited academic computing guys who thought this TCP/IP thing was the great thing, and the administrative computing guys who thought they were completely nuts. That S&N was the way of the future. So sometimes you have to challenge the status quo. And you need to invest in platforms that support innovation. So that's what we're talking about doing. And R&E networks are a great way to do that. And one reason is today's R&E networks bear a lot of resemblance to the commercial networks out there. If you look at the diagrams of the Internet 2 network, it's based on dark fiber IRUs, dense wave division multiplexing, there's Ethernet, there's IP, there's MPLS. The configuration of our network looks a lot like the configuration of a lot of the other networks out there. But we have a mission to innovate. When I first came to IU from the commercial sector, I couldn't quite figure out what motivated people. What motivates you? There's no revenue here that you're getting. What motivates you? Well, what motivates you is due to the next cool thing, to invent the next cool thing before the guy next door does it, right? And that's what we're all about, and that's why we build that thing. So that's what makes us different. We're scaled for cutting-edge technologies. The Internet 2 backbone does not have 3,000 routers on it. It does not have hundreds of thousands of customers. It looks a lot like the other networks, but we're scaled where we can take things that are very cutting-edge, we can get them out there, and we can do it quickly. And we have a large community, researchers, students, and for all of you, these are the next generation of developers, of engineers, of folks that are going to staff your companies. So here's a little bit about NDDI. So it stands for the Network Development and Deployment Initiative. Again, the founding partners. And the mission here is to create an open, global scale platform based on SDN to enable the next generation of innovation. If you're interested in more, there's a link there. There's actually some really good documents there that go in really gory detail about why we're doing this and exactly what we're doing. So the origin here, so one of the origins is, so Internet 2 is run by its membership. The members tell Internet 2, here's what you should be doing. And they said, you need to go build this national Ethernet exchange. And we want it to be 100% self-service, meaning we want our users to be able to go in. They want an Ethernet connection across the country, whatever 2 ports they want, completely self-service. They go in, they set it up, traffic flows over it, monitoring set up, both through a web API and through a programmatic API, and said, oh yeah, and by the way, you can support OpenFlow. That would be kind of a cool thing too. But then we looked at SDN and we said, if you're going to build this kind of network, the way you build this is on an SDN architecture. You want to build a programmable network that people can go in and configure. You want it to be flexible. This is the way we want to do it. And there's this other thing going on, been going on for a couple of years, called Genie, which has been talked about a couple of times. I think we have, there's some folks from the Genie project here today. Genie stands for the Global Environment for Network Innovation. This is a National Science Foundation funded project, and the goal of Genie is to build a unique virtual laboratory for at-scale network experimentation. Want to build that on a shared, heterogeneous, highly instrumented infrastructure. So if you want to do experiments great, you can go out and run them, but you also need instrumentation there to figure out whether they did or they did not work. The other goal is to enable deep programmability throughout the whole network, and for you who've been here for a couple of days, I think that's a theme that we've heard over and over. So here's a little bit about the architecture. This is really high-level architecture, how we're going to go about building this. Right? So this kind of looks pretty familiar, I would think, from what you've seen over the last couple of days. So it's OpenFlow, it's SDN, build a virtualization layer, and then be able to plug in multiple experiments, multiple services, and slices on top of that. So the idea is that you can deploy this across the whole network. Different experimenters can come in and deploy new things on top of the infrastructure. So the first thing we built is what I described. Don't ask me questions about the technical details. We have folks who build all of this. But it's a service called the OS3, the Open Sciences Scholarship and Services Exchange. And this is what I talked about in terms of building this nationwide Ethernet fabric with 100% self-provisioning. And so this is sort of the software architecture that, again, we have a demo here. It's actually live. We have 4 switches in the field today with a 5th coming, and starting to connect beta customers with a goal of going production by the beginning of next year. All based on open source software. So OpenFlow switches, the Knox controller, open source controller, an abstraction layer that we have built on top of the controller, and then an open source application on top of that. Shortly, I think after the first of the year, all of this will become open source, and the goal is to get other universities, other networks, to take this and deploy it, to put it out there to get people using it as a platform for innovation. If you look at what we've done here, put a lot of time, a lot of thought into building the same things that you would think about building your networks in terms of scalability, redundancy, security, all of that, baked into here. So when I think about what kind of innovation we're going to support, how we're going to do that, I really break it down into 2 pieces. And one is sort of the evolutionary innovation, which is to take the existing control plane functionality and build that on top of this new open architecture, which lots of people can get and build on. Right? This is what the National Ethernet Exchange Service is one piece of. Right? So you could go build something like that on a traditional architecture, but let's go build it on this new open architecture so then we can innovate it going forward. We're not going to stop by just replicating building VLANs across the country. We're going to build on top of that and move that forward. The other piece is the revolutionary part of this, which is what the Genie project is doing, and we're going to move with the architecture you saw onto the NDDI infrastructure, which is let's create a test bed using the same technology that we're going to go build our production services on. Let's build a test bed for this, let's slice it, let's virtualize it, and let people go out and try things. Again, like Rob said, we don't know what they're going to do. Let's build a test bed and let people try things. So here's the obligatory diagram that shows what we're building. There's roughly 35 nodes on there. The yellow lines show what we have built out today. This is a 10 gigabit backbone. We have the capability in the hardware. We already have the data to do 40 gigabit. And over the next year or so, we're going to build out the rest of the network. So you want to jump in?
So the last piece is a call for participation. So this is, I said when I started my talk that, the we that Internet 2 was formed by is a community. And it's a community that involves academia and it involves corporate partners. Anyone in this room is welcome to use this platform. We think with NSF's extensions that they're working on the campuses, that within a year or 2, you're going to see a very rich, multi-domain SDN environment that potentially gets you end users, labs, all kinds of devices, etc. And we want this to be the platform where people think about trying these large experiments. We've got partners in Europe, in Asia, in South America, who are already signing up to connect with this. So we think this is a place where large-scale innovation can happen, and we welcome participation from anyone that wants to be part of it.
Would they call you if they wanted to participate? I'm going to ask that question. But wait, would they call you if they wanted to participate?
They go to that website and absolutely, that'd be great. We can trade cards, whatever.
You're coming soon, Steve. Don't worry. I have 2 questions for you guys. First one is, there seems to be a lot of parallels between kind of the DevOps motion or DevOps movement on the system side and kind of the vision that you guys are talking about for taking this infrastructure layer and creating an environment where you're free to program it and do all of these things, and you're expected to take responsibility for that. What kind of things need to happen at the academic and education level to kind of build that competency, to build the willingness to work at that? Because I feel like that's a huge kind of hole that people kind of randomly fall into.
Yeah. Actually, did I give you that question? You sort of teed that up for me. So that's exactly what we're working on, is getting the students, the researchers, and the IT professionals at the universities together. I mean, that's what the Genie project is pushed for. That's what the center we have at IU is our main focus, is to train the students, get them involved so they're not just sort of out there doing whatever. Get them involved with the people who are running the networks. Get the researchers involved with them and get those teams working together. So I think that's how you generate that environment.
Who isn't kind of getting involved? And I'm not talking about company names, but I'm just trying to think of, established companies. Do you see kind of more entrepreneurial students kind of just going their own way and finding, it still sounds very regimented for what is kind of so far developed in a very ad hoc manner.
I actually think everyone's getting. I think the excitement's growing, and that's part of the reason why we want to get this out there. I think we're going to see participation from all sorts of places. And I don't think there's anyone who's really not participating at this point.
Okay. And then the first thing I thought of when I was kind of understanding what you guys were doing was kind of the idea that a network as a service, when you're talking about a self-provisioned Ethernet network. Why is that necessary today when I'm thinking if I, as a developer or someone, is going to go out and build applications on a platform or an infrastructure that's already out there?
So I'll take the first step of that. I mean, within our community, we have examples of applications. Folks who, the high energy physics guys are always the poster child, who want to transfer very large files, and they have very customized ways to do that, and they want to do it in ways that are better than TCP. So, you get an environment like this, they can take the file transfer software that they've written, they can integrate it with the network, and literally stand up a network on demand that accomplishes their goals in a different sort of way. We've got examples of that in the medical community and elsewhere where, there's some very specialized applications where if they had access to the network and they could just tweak it a little bit, they would probably have a much better experience over distance or at scale.
The right answer was, if I could predict that, I'd be starting that company and making millions of dollars in the next few years. All right.